I guess Teacher Jennifer's mic is muted. Teacher Jennifer is going to read the session today. Jennifer, can you unmute your microphone?
Can you hear me?
Yeah, now we can hear you.
Yeah. Okay. Good morning, everyone.
Yes, good morning.
Yes, I think we're going to look at the Mr. Field. Can you scroll up? We look at this exercise. I think we didn't look at it. The number machines.
Yes, we didn't look at it.
So the number is still low. I don't know. Can we continue or we wait for some
continue?
Okay. Yes, when you look at this exercise from the previous exercises, we have this machine, and in part A, we have this number 7, which is coming into the machine, and there is a +2 inside, and they're asking us to get the outcome. Now, what do you think would be the outcome of this machine? Because we are seeing how these numbers come in the machine, then when they do some additions, what will be the outcome? Someone raised their hand. Chirabo?
The outcome.
The outcome of the machine. Hello?
The outcome of the machine would be 9.
Would be 9. How do you get 9?
7 + 2 = 9.
Yes, so the outcome of this would be 9. So it's like we are getting numbers, then you have to look at what sign is here. So we have an addition here. So 7 + 2, we shall get 9 as the outcome. Then we have part B. We have part B, where we have, yes, with that idea, I think I can see people's hands up. Can we get these people to answer these numbers?
Yes, we can have Bridget.
Yes,
Bridget, please.
Part B?
Part B is 3.
How do you get
the
3?
answer? Get 8 - 5 = 3.
Exactly. Thank you. So because we have this -5, we have this 8, which is coming in to join this -5. So the outcome will be 3. Another person, part C.
We can have Kwagala. Kwagala, please unmute and go on.
The answer is 23.
Answer is 20.
23.
Good. We are getting 14. 14 is coming into the machine, and this 14 is being added to 9 in the machine. Then we have 23. Yes, I hope that one is okay. So we have question 2. We have question 2. The sequence 1, 2, 3, 4, 5, etc. is put into each number machine. Now, what does each machine do? We have these numbers. So what has this machine done? we have a series of numbers from 1, 2, 3, 4. These dots shows that the numbers are still continuing. So what has this machine done to arrive at this 11, 12, 13? There is a missing number here, 14. Hello, can you make that correction? There is a missing 14, then 15 and so on. So what has this machine done? So many hands are up.
Yes,
Okay.
I can see many hands. Can we hear from Esther Atwere? Esther?
It has added 10. 10 plus 1, we get 11. 10 plus 2, we get 12. 10 plus 3, 13. 10 plus 4, 14. 10 plus 5, 15.
15.
Okay, thank you. So where you are seeing a question mark, it implies that you're supposed to put there plus 10, okay? Meaning that whichever value you are putting in is supposed to be added to 10 together out. Okay? I hope that's clear. Can we hear from Narure, Rukia, Shugi?
So part B.
Yes, part B.
Chair, for number 2, I think it's 1 times 10.
It's 1 times 10. So what do we put where we're
Chair,
having?
for number 2, I think it's 1 times 10, then you get 20, and 2 times 10, you get 5. Yes.
So generally,
Yes.
what is
For
supposed to be?
you say 1 times 10, you get 10, then 2 times 10, you get 20. Yes. Then 2 times 10, you get 20.
Okay, okay. Yes, please.
What's the principle in getting the formula, the process?
The process, you look at what you put in and you compare with what you get out. Eh? So you try to look at the relationship. You look at
What I mean, like, what formula do you use to get the process? Like, let us say they give a totally different number. Yeah, I'm just trying to understand there. Like, how do you get the process? Because in certain numbers, like the process might, the answer you get might not be the process. So I'm just trying to understand how you get the process. Yeah.
Okay. The process, maybe I can simply use you eat food. Eh? So every time you eat food, it is the input. Those are the numbers you are putting in. Eh? Now, when you eat, there is a process that takes place in your body. Okay, the digestion and all that. And then at the end of it all, you get something from your body. Okay. So the question, I mean, if I'm trying to use that analogy, we might not have a general rule as per se. What we do is we try to look at what has come out of the machine, and then we try to compare with what we put in. And then we try to relate the two, and that one guides us on what kind of relationship the input and the output is having. So take an example of part A. If you look at 1, they are telling you that it's being put in a machine. Now, when it's put in the machine, there is a process that takes place. Now, at the end of it all, you are getting out an 11. Okay? So when you compare 1 and 11, okay, what comes in your mind? Because you put in a smaller value, which is a 1, and you've got out a bigger value, which is an 11. So what happened to the 1 is what should be ringing in your head.
It must have been added with a number.
Yes, it must have been added with a number. It can be multiplied with a number. You think through, just think outside the box. Eh? What could have happened to 1 for you to get 11? What could have happened? You get it?
Yes.
So you always think, you think through the whole process. Just think outside the box. Eh? There is no general rule that you're going to be using. Okay?
Okay. Yes.
Yeah, you basically look at the relationship between what you are putting in and what is getting out.
Yes, teacher. Thank you.
You're welcome. Tia Jennifer, over to you.
Yes, can we move on to part C? Yes. in part
Excuse
C-
me.
Yes.
I was just requesting if you could repeat for me because I had just joined.
You just joined. Okay, we are looking at machines and how we can use these machines to get out. How can we put numbers in the machine so that we get out some kind of a pattern or a sequence? Okay, and we've looked at part A, whereby when we put in these numbers of 1, 2, 3, 4, 5, we are getting out 11, 12, 13, 15. Okay, so the question they're asking us is, what would have happened to the numbers we put in the machine for us to get the numbers you're seeing there? So in that circle you're seeing with a question mark, there is something that happens. Okay, there is like an operation that we make on the numbers we put in the machine. And that operation is what the question is asking you to put, okay? Where you're seeing a question mark. So if I took, for example, 1 and I put it in a machine, okay? And then out of the machine, I'm getting 11. So what happened to 1? You realize that for you to get 11, you have to get 1 plus 10, okay? So the operation on 1 is plus 10. That means plus 10 is going to be the rule we are going to use for all these other numbers in order for us to get the output. Okay? Does that make sense?
Hello.
Yes, thank you, teacher.
You're welcome.
Mhm.
Okay, Jennifer, can we move
So
on?
we can move on to part C.
Yeah, but I'm seeing so many hands. I don't know if they are all having questions in relation to what we are doing. Our default, can we hear from you?
So I want to give the answer for part C.
Parts, you
Oh,
want to answer parts. Okay, can you go
Yes.
for it?
Part C.
For part C, the number machine multiplies the original numbers by 7.
By 7.
Yes.
Okay. So we have 1 times 7. The outcome will be 7. We have
2 times
2.
7 is 14. 3 times 7
Yeah.
is 21. And the rest.
So the rest, 5 times 7, we get 35. So this is how this machine in part C has operated. So you just need to know, like here, where you have a question mark, what number is being put, and then you look at the operations. Is it addition? Is it subtraction? Is it multiplication, whole division? Then you'll be able to get these results. Okay, we move on to part D.
Part D, can we hear from Mutamba Primrose? Your hand has been up for some time. Mutamba?
The answer for part D is we add 1.5 to each of the numbers 1, 2, 3, 4, 5, such that we have 1 plus 1.5 giving us 2.5, 2 plus 1.5 giving us 3.5, then 3 plus 1.5 giving us 4.5, and the rest.
Oh, thank you very much.
Yeah, you're welcome.
That's good. So that was question 2 of the number.
Teacher.
Yes.
Teacher. So before you leave that, like on C, can't you just say that 6n plus 1?
Yes.
Here in the box, you put 6n plus
you-
the
6n plus
numbers
1.
Yes, you have to get these ones.
That's like getting a general rule for the nth that can help you get the nth term. Let me see. 6. Okay, let me try to go to the Blackboard and I see what you're going to get out. So you're saying 6n?
6n plus 1
plus
plus
1.
1.
Okay.
6.
So
6. times 1 plus 1, you get 7.
Yes.
Then 6n plus that 2, the next number in the sequence, you get 6 times 2 plus 1. Yes. Huh?
6 times 2
Times n
plus 1
plus 2. No, plus 2.
plus 2.
This is 2.
Yes.
But you see it won't, so that's 14. Okay. Let's go. We'll see.
Then,
See if we are doing the right thing. I have 6
then
times
6 times 3 plus 3. You get 21.
Okay.
Then 6 times 4 plus 4. You get 28.
Okay, great. I think you're trying to think outside the box, and this is good. But you realize that the pattern you're having is 6n plus n. You see that? Because you're increasing this and that. You see that? You keep increasing that. Same
Teacher,
rate.
I
Yes.
didn't mean that you keep increasing. Like there are commas, I think you just said 6n plus 1 for the first number. Then for the second number, you say 6n plus 2.
6n plus 2.
Yes, because like you're getting the second number. After
that's why I'm saying that if you decide to say 6, to use an n, that means we can start from the smallest natural number, which is the one, and we keep increasing to see if it gives us a consistent pattern. But you realize that what you're doing, it's like you're doing it manually, basically. Okay? So when you say 6n plus, 6 times 1 plus 1, 6 times 2 plus 2, 6 times 3 plus 3, the general thing you are doing is 6n plus n, because you keep substituting where there is n, you keep putting the natural numbers. But 6n plus n is basically 7n. You get it? So it's as good as saying you keep adding 7. You
Thank
get
you,
it?
teacher. Thank you.
So,
Yes.
you can use it, but it is not the best thing to use in a machine. You might end up getting confused along the way. Okay. Yeah, but thank you for thinking outside the box. That
You're
is
welcome.
what we expect our students to do. Okay, Teacher Jennifer, you want to continue?
Yes, can we move on?
Okay, let me go back to, are people seeing my Nana's guide?
Yes,
Yes.
I think.
Okay, great. So,
yes, we move on to the question 3. Question 3, they want us to write down the first 5 terms of the sequence given by each of these formulae. So we have, remember, we are writing the first 5 terms. So we are given these formulae. We have part A, 9n, 12n. We have 2n plus 4, 3n, minus 1. And we have E is 3n minus 2. Now in this formulae, they want us to generate the first 5 terms in each of these numbers. So how do we get that? Part A, what are the first 5 terms?
Teacher Jennifer, I'm thinking that since the girls you're having, able girls, might think of giving them an opportunity to go through this work on their own.
Okay.
other than-
Actually, since we did
because these are supposed to be exercises that they're supposed to practice. So what we are going to do, we are going to put them in breakout rooms. Then we can take maybe 10 minutes there, and they try to work out number 3, number 4, and 5.
Number 5.
So when you return, we can ask them to share what
Okay, what they would have come up with.
From their rooms.
Okay.
I think that would make more sense. I'm seeing we are 210. So
We can break
11 groups, approximately we'll be having 20 girls per group. So let me open the groups.
Okay.
And the girls have been randomly assigned in 11 groups. So they should go to their groups and discuss from there. The teachers, you can try to join the groups, and you try to help them in case there are questions they are having. You know, you moving from group to group as you try to see what they are doing. So girls, can we move to our groups and then we discuss from there? I expect everyone to have a copy of the runner's guide. But we cannot project in each and every group. Okay. So the girls are just joining. You can pick a group and you go in there if I've not assigned you. The girls who are not yet assigned to groups, please, can you pick a group and join in? I can see some of you are still in the main room. Just pick a group. There are 11 groups. Just pick a group and you join. Okay. And make sure when you're in that group, you actively participate with your group members. Desire, someone is asking, how do we pick a group? You can pick a group by, if you check down there, there is where there are breakout rooms. So when you click on that icon, it will bring out different rooms. Okay. So from there you can join any group, because you came in when we had read assigned. So you click on that and then you join it. It has an option of joining. Okay.
Host, could you put me in a room? People, what are we doing? Where are other people?
Oh. Yeah. Your microphone is unmuted. You can speak it. Don't speak, it's okay.
Excuse me, I've just come right now. My connection was not good, and I'm asking, where are we now? Bruno, I request you co-host Mr. Theod. Thank you. Yes, Marjorie, your hand is up.
Oh, teacher, I was just asking if someone is saying, I think I wasn't listening. That's all. Like, I wasn't hearing a thing. Yeah.
St. Joseph, can you project the learner's guide? Because it looks like Mr. Theo is off.
Yes, but someone is sharing. I don't know.
Oh.
Maybe she needs to first stop sharing. Okay. Hope that is okay. Is everyone able to see my screen?
Yes, we can see it.
Okay. Maybe Teacher Jennifer can take it away. But I can see Kirav is having a question. Maybe first we attend to her.
May you please make the letters a bit bigger?
I can zoom in if that is okay.
Yes, thank you. That's enough.
All right.
Okay, it looks like Teacher Jennifer is also off. Girls, can we kindly share what we discovered in our group as Teacher Jennifer reconnects? We are looking at number 3, part A. If I can see some hands, can you help choose some of the girls?
Okay. Let's hear from Vanessa. Vanessa, please unmute and okay.
And for us, group 11, we found that part A was 9, 18, 27, 36, and 45 because we multiply 9 by 1, 2, 3, 4, and 5.
Okay, that's very good.
Okay, that is beautiful. Okay. All right, let's have part B.
Lina, please go on.
In group 6 for part B, we found the sequence was 12, 24, 36, 48, and 60 because we multiplied 12 by 1, 2, 3, 4, and 5.
Okay, that is interesting. Thank you. And then we move on to part C.
Part C, we can have Miro, Gloria.
In group 2, we say that part C is 6, 8, 10, 12, 14, because you multiply 2 by 1, 2, 3, 4, and 5, and then you add 4.
Okay, that's great. Then part E, we can have Tendo.
Tendo.
Okay, Bethro.
Okay. So in part D, we use the same concept and it said that 3 times 1 minus 1 is equals to the first one. Then we got the sequence as 2, 5, 8, 11, 14.
Come again.
We used counting numbers to find the numbers in the sequence. Like now the first number would be 3 times 1 minus 1 is equals to 2. And then 3 times 2 minus 1 is equals to 5. Then 3 times 3 minus 1 is equals to 8, like that, up to the fifth number.
Okay. Ori, you gave one for D, though I wanted E. Anyway, thank you for that. Let's hear from Michelle. Michelle giving us part E.
Part E, the question was 3n minus 2. So we got 3 times 1, which is 3, minus 2. The answer will be 1. 3 times 2, which is 6, minus 2 is equal to 4. 3 times 3, which is 9, minus 2 equals 7. 3 times 4 equals 12 minus 2 equals 10. 3 times 5, which is equal to 15, minus 2 is 15, minus, which is equal to
and the sequence was
1, 4, 7, 10, 13.
okay. Thank you very much. Let's say to question 4. If you did it. I request. Okay, Gloria.
Let's have Primrose.
Question A part 1, question 4 part 1. Say that what is the 10th term of the sequence 2n minus 1. So we shall replace n by 10 to get 2 times 10 minus 1, which is 20. 20 plus 1, giving us 21 as the answer.
Okay, thank you very much. Let's hear from Adeki, giving us part C very fast. Adeki?
For part C, they said, what is the 5th term of the sequence 4n plus 1? So we shall get 4 times 1 plus 1, which is 5. So we shall say 5 times 5, which is 25. So 25 is the 5th term of the sequence 4 plus 1, 4n plus 1.
Really?
Yes.
Part C of question 4, right?
Part C, where I say the 5th term of the sequence. Is it part C or part B?
Part C of 4.
Yes, part C of 4, they say, what is the 5th term of the sequence 4n plus 1? So we're supposed to first find the first number in the sequence. So we shall say 4 times 1, which is 4, plus 1, which is 5. So since they want us to get the 5th term, we shall say 5 times 5. Then the answer will be 25.
But remember, Adeki, we are using a formula, okay? The formula you're having as 4n plus 1 is general. It can help you generate all the other terms in the sequence, okay? You don't need to first find the first term, okay? What you need to do here is to substitute 5 for n to have, because the n you're seeing here is representing a sequence of counting numbers or natural numbers, okay? And those are 1, 2, 3, 4, 5, and so on. So if they ask you for the 50th term, it will be like finding 5, identifying 5, which is the 50th term in the natural numbers, times 4 plus 1. And that will give you 21 directly. Hope that is okay.
Sir Joseph, can I make some more clarity?
All right, please.
I think these girls need to understand that n stands for the position of those natural numbers. So whenever you see n, it's like the position of that number. In this case, you realize the question is asking us the 50th term. That means the number in the 50th position. That means where there is n, you put that position and then you work out the number to get the term of the sequence. All right, thank you.
Good. Very good. Okay, maybe lastly for that, let's have Anita Birungi to give us the 70th term, that is part D.
So on part D, we say 5 times 7 minus 1, which is 35 minus 1, and we get 34.
Okay, thank you very much. Maybe before we proceed, let's hear from Gladys. What do you have to say generally about question 4? Or if you had any concern?
No, I wanted to give an answer.
For
any number that picked me, but they didn't pick me. So it's
okay, part B. Part B, what was it?
For part B, the answer was 30.
And how did you get 30?
Since they said what is the 8th term of the sequence, 3n plus 8, I got 3 times 8, since they said the 8th term in the sequence. 3 times 8 plus 6, which 3 times 8 is 24 plus 6, which gave me 30. Yeah, that's how I got it.
Okay, thank you very much. We have about 5 minutes. So let's look at question 5, a few numbers that we shall look at for that case. And let me go there very fast. That is question 5. Hope you're able to see that. Are you able to see my screen? Hello?
Changes if you can see it.
Okay, please. I request someone to read for us the first question 5. Just the open statement.
And you can read for us. You can read for us. Ivy.
Okay, we can have Esther, Lucky, very first. Esther, please go on.
Draw double machines that can be used to get each of these sequences from 1, 2, 3, 4, 5.
Okay, we looked at number machines. Okay, that was page page 82, okay? The first part. So what you're given as 1, 2, 3, 4, 5, 6 is the input, okay? And what you're having as the parts A, B up to E are the outputs, okay? So they want you to determine what the number sequence is processing to give you each of the numbers or each of the sequences in the parts A to E, okay? So I request someone to, because of the 2 minutes we have, I don't think we shall have time to draw the number machines, but you do them as your homework because this is an exercise. But I request someone to take us through what a number machine does to have a sequence A, or to generate for us a formula for part A very fast. Someone to do that? Melissa? I think we have lost her.
We can hear from Narubega Esther Rusi. I can see her hand is up.
Okay.
Esther? Can you hear from Ivy Kengoma? Ivy? Ivy?
Esther was giving a view, but okay, Ivy, maybe. Esther, are you ready?
Yeah.
Okay, what's the formula for part A?
It will be 1 plus 4, we get 5. 2 plus 4, we get 9. Sorry.
But remember that, Esther, we are generating a general formula that will give us a sequence. Okay, you can't have separate formula for each term. Eh? So we want you to look at, if you're having that term along which is given in part A, what is the general formula for generating all the terms in that sequence? Okay, maybe Gladys, very fast.
For the first one, the formula is 4n plus 1.
How do you get that?
First of all, I first got 9. I first got 5 and subtracted it from 5. Then I got 4. If you get 4 times 1 plus 1, we shall get 5.
Okay.
Yeah, for number 2. Should I answer number 2?
Okay. Maybe before we go to number 2, could you help your friends understand how that term can be used for the next output? Eh?
Okay. You see, if we get this formula that are formed for n plus 1, and if we get 4 times 1 for n plus 1, 4 times 1 will give us 4, plus 1 will give us 5. It's the first digit there. Then if we continue 4, and at the second part, we replace this n with a 2. So it will become 4 times 2 plus 1. 4 times 2 is 8 plus 1. It will give us 9, which is here, the second one. The other one is 4 times 3 plus 1. 4 times 3 is 12. 12 plus 1 is 13. Yeah, it will get there.
Okay, thank you. Joseph.
Yes, please.
Joseph. Yeah, I'm thinking that in the interest of time, because we seem to have used our time.
Yes.
In the interest of time, we can end it here. But maybe we need to inform the girls that we are going to post an exercise which is going to cover all the work that we've been doing since we started. So we'll expect you to use the knowledge that you have so far acquired for the patterns and series. And I'm thinking that maybe next Tuesday, if there is anything which is not clear in the topic, perhaps in that session we could it could be a question and answer session kind of, so that we do not leave any girl with some kind of gaps as far as this topic is concerned. So on Tuesday,
Yes.
I'm thinking that instead of us starting on something new, we could do a Q&A kind of.
Yes, please.
Yeah, but yes, go
I
on.
can see a number of hands, but given the time, because the girls need a break, I think I request them to ask through Google Classroom. You shall be able to answer them right away, because given 9 or 12 hands, you might use like 20 minutes.
Yeah, let's not encroach on the next on their break as they prepare for the next class.